Exercise set 1.3.3, question 15. Pelicans tuck their wings and free fall straight down when diving for fish. Suppose a pelican starts its dive from a height of 20 meters and cannot change its path once committed. If it takes a fish 0.1 seconds to perform evasive action, get out of the way, at what minimum height must he spot the pelican to escape? Okay, well, let's look at what we've got. We've got a pelican diving 20 meters, and he wants to get this little fishy, huh? Let's pick down as positive. Let's put some numbers together. The velocity initial of the pelican diving down is 0. You know he's free falling, so he has to accelerate at 9.81 meters per second squared. We know this displacement right here is 20 meters. We don't know how long it takes, but we're working in terms of time because we know the fish needs 0.1 of a second, so we should figure out how much time it takes the pelican to reach the fish. And we can do that with our VIT equation. And we know this is 20. We know this goes to 0. So write out 1/2 times 9.81 t squared at 20 equals 4.9 t squared. Divide both sides by 4.9, and then take the square root so that we end up solving for t, and we'll see that it's 2.02 seconds. That's if he reaches the fish. Now the fish needs to see him 0.1 of a second before that. The fish needs to see him at 1.92 seconds in order to avoid him. So we need to figure out how far down the pelican has fallen in that amount of time to see how much, at what height the fish needs to see him. So let's redo the calculation only with 1.92 seconds. And this time solve for d over that time period. We don't know d. We know this is still 0 plus 1/2 9.81. Very fussy pen. .81 times 1.92 squared. And we get a displacement equals 18.1 meters. There it is. So the pelican will have dropped 18.1 meters out of the 20. So that leaves how far above the fish? It looks like 1.9 meters then. So the fish must spot the pelican almost 2 meters above him, 1.9 meters, in order to avoid him.